family ties and safety nets. What an interesting one. Let's hear from Erich.
Thank you for the opportunity to speak to you today. As part of the theme of value of collections, I would like to tell you how our herbarium collections and the very important information we get from the specimens contribute to food security. I want to start this presentation by talking about food security. As you know, and can tell from this picture, the term might mean different things to different people. The United Nations Committee on World Food Security, though, define it by saying that people should at all times have access to sufficient, safe, and nutritious food that meets their needs for an active and a healthy life. The harsh reality is that although there is estimated to be more than 7,000 species that has been used for food, most of today's food is derived from only 30 species. Let that sink in for a moment. To go even further, it is estimated that over 50,000 plant species in the world might be edible. It is staggering to find that only 10 crop species account for 60% of the world's caloric food intake. These include grains, a few tuberous plants, some legumes, yams, and a member of the banana family called plantain. Amazingly though, more than 50% of the world's population relies on the top 3 grains alone. No surprise, these are maize, rice, and wheat. The really bad news though is that our food security is under severe threat. Over the coming decades, a changing climate and other environmental stresses will have a significant impact on food security. In some parts of the world, this will result in reduced crop yields from heat stress and reduced water availability. On the other hand, it will lead to extreme weather conditions, and large storms are likely to cause flooding that will have disastrous effects on crops in the region. The crops will literally drown. As if too wet or too dry crops is not bad enough, too wet or too dry conditions will also lead to other problems like disease and pest outbreaks. And this will eventually lead to even more harvest losses. Okay, that was the bad news. Now for the good news. We are already doing something about this. The good news is that we can change crops to be better adapted to the pressures of climate change. To be able to do this, it is essential that we understand that we conserve our crop wild relative plants. Wait, what is crop wild relatives? If this is a new word to you, these plants are wild, or if you like, naturally occurring plant species that are closely related to cultivated crops. These species can potentially donate beneficial genes to crops in breeding and plant improvement programs. To put it very simply, crossbreeding a cultivated crop with a crop wild relative with beneficial genes can lead to a plant better adapted to a different environment. One example is a plant used to a cool, wet climate could, through several iterations of crossbreeding, be better adapted to a warm, dry environment. I'm no expert in plant breeding, so there's of course a lot more detail to this. Firstly, I said that we need to understand crop wild relatives better. A part of that is understanding the taxonomy of these species. This is key to unlocking their potential in plant breeding programs. Our taxonomy is based on studying our plant collections and understanding that taxonomy and classification of plants help to identify plants with potential traits, and these traits will include things like improving tolerance to abiotic pressures such as drought, heat, and flooding, improving crops by increasing their resistance to certain pests, and in general, overall increasing of crop yields due to better adaptations to the new environments. Taxonomy gives us the basic understanding to be able to identify the resistance and adaptive traits necessary to provide crop stability in a rapid changing environment. It is very clear that conservation of crop wild relative species is vital for ensuring future of food security. And our collections provide some of the basic ingredients to achieve this. Information associated with plant specimens in science collections is useful in developing conservation plans to ensure future protection and survival of crop wild relatives. We use collections, for example, to develop a list of all South African plants, and we call that the South African Plant Species Checklist. Specimen data of specimens in science collections provide us with distribution data for plants, and also their level of endemism, in other words, to which area or region they are limited to. Specimen data also often contains information of plant use, and it also forms the basis for threat assessments and many other examples. The South African development community recently participated in a worldwide project on crop wild relatives. In South Africa, SANBI partnered with the Department of Agriculture, then it was called the Department of Agriculture, Forestry and Fisheries, and the ARC in running this project. SANBI Iberia was tasked with producing a checklist of wild plant relatives of human food and fodder plants. What we did is we compared a list of known crops with our South African plant species checklist and identified relatives at the genus level. This resulted in a crop wild relative checklist of 1,593 taxa. That's almost 7% of the country's flora or taxa. That's quite a lot. So the list was therefore further refined through a prioritization process which considered the following: socio-economic value of the related crop, the potential use of the wild relative in crop improvement. Obviously, you don't want to cross or breed a poisonous plant with a crop, hoping to achieve anything. The conservation status, and then whether it is restricted to South Africa, or in other words, an endemic plant. Now, most of this information used originated at some level or another from specimen data. This prioritization process reduced the original list of 1,593 taxa to 258 taxa belonging to 33 genera and 15 families. 93 of the 258 taxa on the list were endemic to South Africa. I know it's difficult to see from the graph, but the predominant families on the list was the Poaceae, that includes several grains, the Fabaceae, which are the beans and the peas, and the Solanaceae, the potatoes and sweet potatoes. So all available specimen records for these 258 crop wild relative taxa was gathered. It was collected from different herbaria and citizen science virtual museum platforms, and it resulted in a large data set of about 23,527 specimen records. Now you can see on the map the distribution of these taxa, and you can tell that it covers basically the whole country. After a process of data cleaning and georeferencing the data, it was provided to a conservation biologist to conduct a spatial biodiversity planning analysis. To very briefly explain, they use systematic conservation planning methodology to identify the best sites to conserve priority crop wild relatives. And at the same time, they determined which species are already protected in formerly protected areas. They then prioritized new conservation areas based on the following: the level of endemism, the level of endemic crop wild relatives protected in this area, and also then the overall species richness of the area in South Africa. Again, there's of course a lot more detail to this process that I have time to share with you in this presentation. So the most important sites for protecting crop wild relatives in South Africa was therefore finally identified. And finally, the last step was to engage with conservation authorities and stewardship programs to ensure that these sites are prioritized for inclusion in future protected area expansion strategies. This information was also included in the National Strategic Action Plan And there it sets out a coordinated, systematic, and integrated approach to the in situ and the ex situ conservation of our crop world relative diversity. I want to thank you, and that's all from me. I really hope that you've enjoyed the exciting virtual tour of our valuable science collections for conserving crop wild relatives and enhancing our food security. I thank you. Back to you, Fulu.
Thank you. Thank you so much, Eric. Well, I know I don't want to go hungry, so I'm very grateful for this project. It's so good to know that there's backup for food security. So thank you so much to you and your colleagues for all of this work.